Cast is now starting. All attendees are in listen-only mode.
Good morning. We're just going to give it another minute for people to hop on, and then we will start the presentation. Okay, good morning, everyone. Thank you so much for joining us. My name is Megan Jones. I'm the Climate Program Leader here at the National Weather Service office in Bismarck. And I'm joined by Rick Krolak, who is our Observing Program Leader, but more simply just the Data Manager here at the office in Bismarck. We just wanted to take a little bit of time today and talk about the new 1991 to 2020 climate normals. These were released on May 4th of this month, so you might have already seen a little bit about them. You might have gone into the data a little bit, but we wanted to just kind of go over for our partners, just a little bit more about them and what we've found from them. So just an outline, we're going to go over the background on the new normals, just kind of what they are, how they're calculated, and then go more into some temperature and precipitation data, as well as some local impacts. And then we'll have time at the end for questions and answers. If you want, you can certainly type your questions into the little question box in the GoToWebinar panel, in case you don't want to wait until the end to put it in there, but we will probably just be waiting until the end to address all of them. This webinar is also being recorded, and we will send out a copy of the recording as well as a copy of the slides, because there are a couple links at the end just so you can have them, so don't feel like you have to write those down now. Okay, so just starting out, we want to talk about, just kind of what are climate normals. It's pretty intuitive to us being in the Weather Service, but a lot of people might not know. So climate normals are just 3-decade averages of climatological variables. So we're just looking at temperature and precipitation, things like that, for a consecutive 30 years, and then averaging that. These are produced not by the National Weather Service, but instead by the National Centers for Environmental Information, or NCEI. They are part of NOAA, but it's just separate from the Weather Service. And they do these because this is really international criteria. Being a part of the World Meteorological Organization, they are required to compile and release these climate normals every 10 years. And really, we know what they are, but why should we care, and why are they important? And for us, there's such a variety of ways to use these climate normals. And the main thing is we want to be able to take the weather of today and what's happening right now and put it in a little bit of context over the past 3 decades. You could use these for personal use. If you're planning a vacation, you want to know what the average temperature is in a certain part of the country, you can look that up. If you're curious about local climate, what is our average high temperature in the summer in Bismarck? How much snow do we get in an average season? Those things are really important just for the everyday person, but there are a lot of industries and sectors that really need these to be able to develop plans, especially in the agricultural community. They're looking at when we get precipitation, when we have our first and last frost and freeze, so they can plan when they're going to plant, what crops they're going to plant. All that sort of thing is really important for people. And it is interesting living in North Dakota. I think a lot of people who have lived here a long time or grew up here, my coworkers tell me a lot that normal is not very typical. A lot of the times we do tend to kind of bounce from one extreme to the other. And I think you can see right now as we are in this extreme drought that was, precluded by a very wet pattern, that we really go from one to the other. So sometimes it can be a little hard because we have our normal and we're just not typically near normal, but it is still really important for us to at least have a baseline to start with. So the way that they're calculated, you do get questions on this sometimes just because people will calculate the normals themselves and just think that, oh, you're taking a normal, you just add everything together and divide it by the number and you have your normal, which mathematically is true. But NCEI has a very specific methodology of how they do that, which is why it's such a big deal when these new normals are produced. It takes a lot of time. That's why they're not out until May of this year, instead of just being out immediately after 2020 was over. So in kind of the simple overview is that they're using data from this specific network, the Global Historical Climatology Network, and they do allow for a certain amount of data to be missing each month, but only for temperature, not for precipitation. So they do have a certain way of filling in the gaps and smoothing the data a little bit. And then they also have, this algorithm that they use for discontinuities, and that can be related to a variety of things, equipment changes, things like that. So it's much more complicated than just taking a mathematical average. As far as the stations are included, there is a lot, and I wish that we had a map to show you all how many, but we don't. But there are over 15,000 stations reporting precipitation, and then over 7,300 reporting temperature. And there are some reasons for this. Three of the main sources of these stations. The big one is the Automated Surface Observing System, which is the ASOS. That's found at many airports. That's what we have here at the Bismarck Airport. So you might hear us reference the Bismarck ASOS, the Dickinson ASOS, and our main 5 climate sites of Bismarck, Dickinson, Jamestown, Minot, and Williston. There is also the National Weather Service Cooperative Observer Program, or COOP network, which is a volunteer network. But they do have, we give them equipment. So it's, it's a little bit more formal, and they collect precipitation and sometimes temperature as well. And then the third one that is included for the first time with these normals is COCORAS, which is Community Collaborative Rain, Hail, and Snow Network. So this is also volunteer, but it's a little bit less official than the co-op program where they have, they buy their own rain gauge or things like that. And it's only precipitation. So that's the main reason why we really have so many more stations reporting precipitation compared to temperature, because precipitation is just easier to get from the citizens and having them report that consistently. As far as data included in the normals, there is so much that we can find from these that it's almost a little overwhelming, and we really could have made this presentation incredibly long, but we're not. But, we can find things on a variety of timescales all the way from annual to hourly. And then statistically, we can find averages and frequencies and different quartiles. And it really is, temperature and precipitation are the big ones, but we can find data for snow, dew point, sea level pressure, clouds, wind, that sort of thing. But so some examples, if you wanted to know the average high temperature for a month, if you wanted to know the average precipitation for an entire year, those are some of the simple ones. If you wanted to get a little bit more specific, you could do the average number of days in a certain month with a high temperature at a certain threshold. We can do that with normals. Or you could get really specific to a certain day and find the average high or low temperature on any specific day of the year. So like I said, I will send out a copy of these slides, so don't feel like you have to write down this web address, but we just wanted to show kind of what the main Climate Normals website through NCEI looks like. It'll take you to this US Climate Normals, and then you can do the quick access, and it'll basically take you to this page. And so at the top, you can pick whatever time period you want. You can also pick 30 years or 15 years. So they do have the 15-year normals available with this set, which we're really not going into with this presentation just because, again, there's so much data to go over. But those are available if you want a shorter time scale. So once you pick your time scale, you select your state, and then you can select your station. And so you'll see that this is just a fraction of the list, that we have a lot of stations listed for North Dakota. And we did want to clarify, because this question actually came up right when these were released by one of our broadcast partners, where there's Bismarck and then there's Bismarck WFO. And Bismarck, just plain Bismarck, is the ASOS, so that is from the airport. And then the Bismarck WFO is the co-op site, so that's here at the office. So they are listed separately, even though they are right next to each other, if you know where our office is. But as far as we are aware, the plain Bismarck, the ASOS data, is what is included in our climate products. So that's really going to be the one that we are using when we are discussing climate things. So we just wanted to make you all aware of that. And then when you select whatever station you're looking for, you can get a nice little table with different stats on temperature and precipitation for the annual time period as well as seasonal, or you can do shorter time scales for monthly, daily, and hourly. Okay, so jumping right into just kind of what we are seeing with the temperature and precipitation data. I just want to go over some of the annual maps and then some of the seasonal maps so you can see just what we've been looking at and what we've been discussing here at the office. So this is the annual mean temperature change, and this is the difference between the new normals of 1991 to 2020 minus the old normals of 1981 to 2010, and this is in degrees Fahrenheit. And you can see really quickly what stands out is that most of the country has this pretty steady warming trend, and then you look at the northern plains and you see that that is not the case. And it's pretty interesting that one way or the other we don't have that strong of a trend, but we do have some places that have been cooling, and that's definitely unique to the northern plains. And I know that that's being talked about a lot because that's just not what people typically expect when they think about, how the climate is changing and what's going on. And everyone expects kind of this broad warming, and we're just that one area. There's some splashes when you get over here into the Northwest, but it's really, it's pretty widespread over the Dakotas and into Montana that there is this weak cooling signal at some of our stations. Looking at precipitation, it's the same concept where we are looking at the difference between the new normals and the old normals, but it is percent instead of the actual amount. The percent just helps us put it into context a little bit more because sometimes the amounts can be pretty low, so you wouldn't see that much of a change in just the physical amount. But you can see that, overall we are looking at an increase in precipitation over from the old normals to the new normals. There's a couple spots that are a little bit drier, so not super consistent, but for the most part, most places have seen more precipitation with these new normals. So now that we're getting into the different seasons, so we'll have the same thing with the temperature change on the left, the precipitation change on the right, but it's going to be just for a specific 3-month period. So we start with winter, and what really stood out to me is that we still kind of have this weak trend in the temperatures. It is a little bit more warming than cooling though compared to the annual, but overall not a lot of change. But what was more interesting is that the precipitation change becomes much more amplified, where you have some places with a strong wet signal, and then some pockets of dryness that are a higher percentage. And we do have some thoughts about why that's happening that we'll get to in a minute. But that really stood out to us when looking at the winter changes in particular. Moving on to the spring, this has also really been a big one that people have noticed, is that this is a very robust cooling signal over all of the northern plains when we're looking at the specific spring season. And that's, it can be misleading a little bit to look at just the annual temperature trends because it is, maybe it's the same throughout the year, but I think we're seeing that the seasons are definitely not all changing in the same way, which is really important. So we definitely have this cooling trend over the northern plains for spring. And then precipitation, it's a little bit weaker, especially when we were just looking at winter. You know, a little bit of a dry signal here, a little bit of a wet signal in other places, but it's pretty weak either way. Moving on to summer, this is pretty similar to winter and where there's not really a strong trend in the temperature change one way or the other. A little bit cooler in the west and south central, a little bit warmer in the north central over into eastern North Dakota. And precipitation, again, not too strong of a trend, although it is a little bit more consistent across all of western and central North Dakota that it is a little bit wetter. So that is interesting to see for our summer season. And then finally for the fall, the one season where we are seeing a widespread consistent warming signal. And additionally, when we're looking at our precipitation, you know, western central North Dakota is mostly wetter. So this was interesting to see, as really fall is the main time period of focus where we are seeing some warming. So I wanted to bring these back up so you could see all four of the seasons next to each other. And what stood out to us was it's interesting how, you know, we have our two core seasons of winter and summer that really aren't changing too much. They're certainly not changing consistently, maybe a little bit more cooling in the summer compared to winter, but the trend is not that strong. But then when you look at our transition seasons, definitely cooling in the spring compared to warming in the fall. And I think, you know, chatting with some people here at the office who either grew up here or have been here a while, it's interesting that they have noticed this change in the spring where it feels like those cooler temperatures really just hang on a little bit longer than they did when they were younger. So these two are really the time periods where we're going to be digging in a little bit more to see if we can figure out what's happening. And as far as precipitation, again, the really strong trends in the winter time, which we think we have an idea on, and then weaker trends in the other seasons, although once you're looking at the summer and the fall, it's a little bit more consistent that we are getting wetter, and then spring is a little bit hit or miss depending on what area you're looking at. So we wanted to go ahead and look at the specific numbers for our 5 main climate sites. We are still working on the Williston record. You know, there was the change in location of the Williston airport, so there is still work being done on threading the climate records. So we would not say that these are official, but we did want to include Williston just to kind of put things into perspective for that northwest part of the state. So this is the annual data, and it is from the ASOSs at each of the 5 airports. So we have the old normals average temperature, the new normals average temperature, and then precipitation average for the old and new normals. And what's interesting is that, you know, there's not really one trend one way or the other, and I think we just saw that when we were looking through the annual maps, is that, you know, there's some places that are weekly warming, Bismarck and Williston. Minot is really the only station where we have, you know, a noticeable warming trend. But then it's a little bit offset by Dickinson and Jamestown, which in their annual temperatures both got a little bit cooler for the average. The precipitation, meanwhile, you know, we have 3 that have that are showing more precipitation, and then we have 2 that have actually gotten drier. Which again, thinking back to what we just looked at, that, you know, there was a little bit of inconsistency. But the precipitation with these ASOSs is actually where we are, we have some questions, and I think that was a big motivator for holding this webinar, because it's a little bit tricky to explain, but we think it's important that our partners know kind of what we're thinking in terms of the new normals and the precipitation. So with that, I'm going to turn it over to Rick because he knows much more about all this than I do.
Hi, good morning, everybody. Thanks for attending. And this is a good time to bring this up because since I've been in North Dakota, spending some time in Williston and then the past 10 years here in Bismarck for the last 20 years, I've noticed some pretty strange things. And one of the biggest things that happened around the turn of the century, the late 90s, is all these automated service observation systems were constructed and put up throughout the country. And, you know, late 90s, early turn of the century there. And you can pretty much see, I displayed some a little bit of history on each one of the ASOSs. And the big idea was, you know, we're getting temperature data continuously every few minutes. We're getting precip data. You don't have that guy out there, you know, looking at the sky and taking manual temperature readings. It's a wonderful idea, and this ASOS is great. But however, when you get up into our neck of the woods, you get up into the northern plains, December, January, February, there's some of the equipment that doesn't perform the way we want it to. And that has begun to show a little bit of a trend, a little bit of a discrepancy trend on a lack of precipitation at certain sites. So on the left side, you can see we got ASOS location in Dickinson, Minot, and Jamestown, about when they were installed, actually when they were installed, okay? And the features with all ASOS sites when they all went in is there was a tipping bucket installed for all the rain and snow. And what this is supposed to do is it's supposed to, every time that bucket catches 1/100th of an inch of precip, it's supposed to tip and register a reading on how much precip we're getting. So they were all installed around the same time. The thing is, with the FAA running the Minot, Dickinson, and Jamestown ASOSs, there was no modification to that tipping bucket. And that tipping bucket, I'll explain later, has become a little bit more problematic during the measurement of winter precip. However, on the good side, you know, with the Bismarck and the Williston ASOS, they started out with a tipping bucket in the late 90s when those were installed. However, the problem was identified, and we said, well, wait a minute, we got to put something a little bit better in there. So around 2004, a modified all-weather precipitation gauge was installed. And this does a much better job in catching that snow, that real light snow that we see in sub-zero temperatures, you know, January, February timeframe. And results have been really good with that. So the modifications of those have continued to keep our precip measurements in the wintertime a lot more consistent. So just a quick rundown. I took the latest normals that we got, the new normals, and I compared those troubled ASOS sites to the local co-op site, which is located in the same town or nearby. And you can see pretty much in the highlighted red areas, those winter months, January, February, and March, there's quite a bit of a difference. Jamestown really wasn't too bad. You know, they were a little bit more in line. However, if you look down at December, that's quite a big difference for winter precip. So you look at the annual comparison, 19 to 21, not a real big change, but for being in the same location, you know, and those ASOS that's underperforming, you can pretty much see the results of that. And here's another one with Dickinson. It's especially been, especially recently, has been a lot more problematic. We've got a co-op site, a new co-op observer that's just taken over a few years ago. But that one site at the Dickinson Airport, that ASOS site, if you notice December, there's a big difference. And also, you know, in the winter months, again, a big difference in the precip. And then you can see, you know, in the blue, you know, April through November, they come a little bit more in line. They make a little bit more sense, and they don't seem to diverge as much. So you're definitely seeing a definite lack of precip being caught by those ASOS sites. Okay, and again, there's Minot, same thing. The co-op site compared to the ASOS with those tipping buckets that still remain. And look at December on this one. This one's 0.31 of you know, the liquid equivalent of snow compared to the 0.8 at that environmental station, the co-op experimental station. I'm sorry. So yeah, big differences there. So the discrepancies, and just a little bit of an explanation, is the ASOS tipping buckets were installed and still remain, as I pointed out. And also, just as kind of throwing them in there, our Hettinger site, that ASOS has also a tipping bucket as well. their co-op site is located up the hill not far from them. And Garrison has actually an all-weather precipitation. That's an AWOS, an automated weather observing site, a little bit different than ASOS. Doesn't have quite everything ASOS has, but it has precip and temperature. And that one there is also performing pretty much in line to the co-op site nearby. So again, not very reliable for precip, but this is just mainly during the winter months. The extremely cold months are the biggest notices on those. And these gauges at Williston and Bismarck, the all-weather precipitation gauges, the reason they're better is because they have a double windshield that catches the precip much more efficiently, and it's a lot more reliable. Whereas that original tipping bucket doesn't quite have that catch. It doesn't have the double windshield to catch the precip. So the recommendation would be just to refer, when looking at those airports, at those ASOS sites for climate data with the new normals, just keep in mind that they are a little bit light there during the winter time, and it's just recommended that when searching and doing some research for those, might want to refer the nearest co-op site nearby for each one of those, especially during the months of November through April.
Okay, thank you, Rick. So we wanted to bring back this graph that we just showed with the new co-op data for Dickinson, Jamestown, and Minot. And you can see that at Dickinson and Minot, that actually changes the trend. So with the ASOS data, it looked like Dickinson and Minot were drier, but when you put in the co-op data, they are actually getting wetter with the new normals. And then Jamestown, it just increased the amount of difference from the old normals. So when we were, looking at all these figures that have the new normals in them, but they are really using the ASOS data, that's why we think that especially in the winter, that seasonal map was showing the trends being either much wetter or much drier, and we think that that has something to do with the ASOS versus the co-op data. So what we do about that, we don't really know. We're still thinking about all this, but we did just want to make you aware that using the co-op data is really going to be the way to go if you're looking at a specific site. And if you ever have any questions about, any of that, you can always contact Rick or myself. All right, so going into some local impacts for kind of the last part of this presentation. One of the things of interest is just looking at the average number of days for certain thresholds. That's one of the things we can get with these normals. So the first one is the average number of days with a max temperature of 90 degrees or higher. So, just thinking about the summer, are we having more hot days, fewer hot days? That can just, that impacts the recreational side of things here in North Dakota, the summer temperatures. And it was interesting to see that at all 5 of our climate sites, we have fewer days that are reaching 90 degrees when looking at the old normals versus the new normals. You can see, maybe not too much of a change. Minot especially, not even a full day. Jamestown, 6 days fewer, which was pretty surprising to see that much of a change. I think one of the main things we thought about when making this presentation is we didn't quite know what kind of changes we would see. It's important to note that, between these two average periods, there's only 10 years of difference. So there's 20 years of overlap. So honestly, we weren't really expecting to see a whole lot. Like, we would not be surprised to see not much of a change because it's 20 of the same years out of the 30 years made in these averages. So to see any sort of change, especially like this one at Jamestown, that really stands out to us because that's not too much new data to work with. So seeing a big change, especially in something like the max temperatures in the summer, it's just interesting to us. So you can see all these are getting cooler, and this matches up with the July and August max temperature changes. So we do have all of these figures available for every month, the average temperature, the maximum temperature, the minimum temperature, if there's anything you specifically would like to see. We do have those available, but for our climatological average highs in summer, the highest is 86, and that's the end of July into the beginning of August, so showing both of these. And it's interesting to see that, in the max temperatures are pretty much cooling across the entire area, especially in July. And that cooling is really maximized in the James River Valley and into parts of eastern North Dakota. So that kind of matches up with where we saw the biggest change with the Jamestown data compared to the other sites. One of the things with, the change in climate is a lot of the times the overnight minimum temperatures seem to be where a lot of the warming is occurring. So again, not too surprising. There is some changes going on, especially with cooling, but it is interesting to see that, in our 2 warmest months, that we are cooling, that there's really been this noticeable cooling trend with the past 10 years of data being incorporated into the new set of normals. So on the flip side, we also really care about winter temperatures because it gets a little cold in North Dakota. So this is the average number of days with the minimum temperature of 0 degrees or lower. So the stations in red, that means that they are warming because they have fewer days where the minimum temperature is 0 or lower, so a little bit counterintuitive. But so at Bismarck and Williston, we are decreasing in the number of days where the min temperature is at least 0 degrees. It's definitely more noticeable at Bismarck compared to Williston. But then you see at Dickinson, Jamestown, and Minot that number is increasing, not by a lot, half a day at Dickinson and Jamestown and less than that at Minot. But so this fits a little bit better with kind of these inconsistent trends that we're seeing across a lot of our stations, especially in the summer and in the winter where the trends maybe aren't as strong. It's not too surprising to see that we're seeing different things at different parts of western central North Dakota. But so looking at the minimum temperature change for January, which is when we are at our climatological lowest, I think it's 2 degrees, at least at Bismarck. And you can see that, some places are a little bit cooler and some places are a little bit warmer. So kind of makes sense with what we saw between our 5 stations, that they're, 3 one way, 2 the other. So that kind of fits that there's not maybe as much of a strong trend compared to looking at the max temperatures in the summer. So the last thing we wanted to talk about is the frost and freeze date changes. And this was kind of on our mind because if you didn't know, we just started, I guess, our frost freeze products on the 15th, so kind of signaling the growing season. So really thinking about things like this. And I think I spent a lot of time chatting with our frost freeze focal point, which is Todd Hamilton. And I think one of the things that we said was, there's only 10 years of new data, so we really didn't know what to think in terms of what we would actually be finding if we looked up the specific dates of the frost and freeze dates. But all of this data comes from the Midwestern Regional Climate Center, the MRCC. And we have our 5 main locations. For Williston, we did use the Williston Experimental Farm. Looking at the MRCC website, they still are having some issues with the combining of the Williston Old Airport and New Airport. So the Williston Experimental Farm did have consistent data back to 1956, so we chose to use this. But again, with a little bit of a caveat, since it's different than just using the ASOS for the other locations. But for each city, the top row is the old set of normals, and the bottom row is the new set of normals. And then we have the median first hard freeze of 28 degrees and freeze of 32 degrees. The median would just be the 50th percentile. And then the same thing for the spring, the median last hard freeze and the median last freeze. So what really stands out is the difference between the fall and the spring. And if you think back to looking at the seasonal charts, you notice, we talked about the noticeable cooling in the spring season and then the warming in the fall season. So on one hand, we were kind of expecting to see a later first freeze in the fall because it's warming, and then a later last freeze in the spring because it's getting cooler. But also keeping in mind, we knew that kind of made sense, but we didn't really know if it would show up with the data. But interestingly enough, for the fall, which is these first 2 columns, there was a surprisingly consistent trend that we saw. And in fact, at all 5 of our climate sites, that median first 28-degree freeze got later in all 5 of these. And it's not a lot later, you know, it's only 2 days, I think at each of the sites. But again, for only 10 years of new data, that to us is a pretty significant change. Because, you know, that's something that's going to be really important to the agricultural side of our partners, and also just, you know, for the average person. They're trying to figure out when they're going to bring their plants inside, and it's good for us to know because that gives us a better idea of when we can maybe think to start our frost and freeze program. It's maybe not as consistent with the first 32 degrees freeze, you know, but still a pretty good trend where we had 3 of them getting later, and Jamestown by 3 days and Minot by 4 days. So that's a pretty significant change. And then Dickinson and Williston didn't change, which also was not too surprising to see that. It's interesting to look at the difference between, you know, what we expected and what we saw in the fall, and then what we expected and what we found in the spring. So certainly differences here where we did have three of these days actually get later in the spring. Dickinson for both the 28 and the 32 degrees, and then Jamestown for the 28 degrees. But then looking at Minot, Bismarck, and Williston, these actually were a little bit earlier, which they're not by a lot, you know, they're only by a day, but it was kind of interesting seeing that the spring is getting cooler, and yet at some of our stations, we are actually having a sooner last freeze or hard freeze. So a little bit unexpected there, even though it wasn't a big change. And we don't quite know if that's related to we just hit a point in the spring where it's just going to get warmer regardless. We're going to be looking into that a little bit more. But what stands out for me personally is here at Dickinson, where the last hard freeze is 5 days later. The last 32-degree freeze is 3 days later. So maybe something in the Southwest to be looking at, that this is really focused primarily at the Dickinson station. And so looking at the minimum temperature changes for May over here on the left and for September over here on the right. So this is interesting to see that, you know, looking at the change in temperature for May, that the strongest trend is kind of in this southwest corner, which would make sense with Dickinson seeing the strongest trend and seeing later freeze dates. And on the contrary, September, we saw that consistency with the data where, especially for the hard freeze, all 5 of our sites were getting later. And that makes sense, where we see this minimum temperature change is getting warmer across all of North Dakota and really all of the northern plains. So differences in the seasons, but we think that there's some really good information that we can take from that, because that, you know, we are focusing on frost freeze right now, but that is something that is pretty important to our partners. So that is all of the slides that we have. I have our contact information here. Please feel free to send us an email about anything climate related, Rick or myself or both of us. We also have the links to the new normals as well as the MRCC frost freeze guidance. So now we would be happy to take any questions. You can type it into the text box, or I think we can unmute everyone, and then if you have a question, you can unmute yourself and ask it.
Megan?
Yes.
Yeah, JP here. So just to clarify to folks, if you, I just now unmuted everybody, but to speak, you still need to unmute yourself. So there should be a little picture of a microphone that might be red, and if you click on it, it should turn green for you to enter your, or I mean, to unmute yourself to ask your question.
Thank you, JP.
And as Megan said, there's that text box there that you can, if you don't want to speak, you can type a question in there. You can also raise your hand. There's a way to raise your hand, and then we, Megan and Rick, can call on you that way.
Oh, we have a, is that a hand?
There we go.
Oh,
There.
Stop there, Bismarck Emergency Management. Can you hear me?
yeah, we can hear you.
On these websites, since they have the averages or the normals typically, do they also, when you get into them, do they show, or can you research the extremes as well? So that, because like again in North Dakota, the averages, the normals are kind of a mathematical number between the very highs and the very lows. I was just kind of wondering if I could make sure I get the best website to show the extremes as well.
Website for the question is a website for the extremes.
Yeah, something that would help show the, where the extreme high temperatures and extreme lows, and then also precipitation. I think I've got that. I believe I may have that because I tried to look for that when I was doing mitigation plan updating, but it's always good to make sure that I'm using the best, source for that kind of information as well.
Yeah, no, that's a really good question. I am trying to think. Can the public use that?
Yeah, usually folks will, with questions on extremes and that sort of thing, they'll direct the questions to us, and then we have resources. I don't know what is accessible to the public domain or not, but I know on our website, if you're looking for extremes, one of the places you can go is to, I could give you the details on that, but through our website, we have a Now Data section, which will link into that. It's a few clicks in there, but once you get to that Now Data site, then I can direct you into something more what you're looking for as far as extremes and all that goes. I can get you pointed in the right direction on that one.
Yeah, so if you go to our weather.gov/biz, you can go to the climate and past weather and then click local. And Rick is talking about this Now Data tab on the end. All of our other climate products are available here for anyone who's curious. This observed weather, you can pick your location and then whatever time frame you want. But here's the Now Data. So I don't know.
Yeah, it's looking familiar. I think I might have received that those links from either Corey or JP in the past. So it does look familiar. So thanks.
Yeah, of course. And let's see, we maybe had another. Oh, we have a question. Why can I? We have a question. Our question box is just very, oh, there we go. Okay. So the question is, how are the drought conditions throughout the state impacted by the findings and in specific areas, for example, southwestern North Dakota? That's a good question. I don't know if right now the drought conditions are being impacted by these new normals. I think it helps put things into a little bit better of a perspective in terms of what kinds of precipitation we can be expecting, especially with the past 15 years, we have been in more of a wet cycle. So, if we're maybe turning the corner on that and, that's been negatively impacting the drought conditions that are ongoing right now, that can certainly be a factor. I don't know. Any other thoughts? We need Alan here. We need our hydrologist. He's the drought expert. But yeah, I would say that, nothing in particular. But again, it's all just about putting the new anything that's happening right now into a better perspective of what's been happening for the most recent 30 years. Because obviously there have been some changes since the 1981 to 2010 normals. So it's good that we have this new set of normals to maybe a little bit more accurately represent what's going on across the state.
Hey, Megan, I just, the questions were only, for me on my display, were only on one line, and I figured out how to expand them. So there was a question from Erica. I'm not sure if you answered that one yet. Would it be accurate to summarize the changing temperature normals from season to season as simply migrating to a later point in the year? In other words, summer and winter are starting later in the year, but still lasting around the same amount of time. So I guess it's from the data you showed. What I got out of that was that spring is kind of coming a little later, right? Like winter is kind of hanging on a little bit longer.
Yes.
Into spring, and then am I remembering correctly that fall is kind of hanging on a little bit later as well? In other words, the first freeze coming a little later, not only in the spring but also. Or I'm sorry, the last freeze of the spring is a little later, and the first spring, the first freeze of the fall is a little later.
Yeah, and I mean, I think, the shifting of the seasons is one of the biggest things that we've pulled from this, because I think when people think of climate is changing, they think that it's just warming and that's it. But looking at this kind of shift of the seasons is also really important, because we know that that's going to have an impact on people here, especially the agricultural community. And I think, keeping these consistent, purely meteorological seasons, September, October, November versus March, April, May, those are still going to be our seasons. But I think, when you think of personally what feels like fall or what feels like spring, I think that is changing. And I think that's one of the main things that we can pull from this new set of normals. And, it might be short-lived. We might get new normals in 10 years and things have kind of gone back to a little bit more, the traditional seasons, I guess you want to call it. Or we might continue this trend. We might keep seeing spring cooling and fall warming, and the winter, being much more of the January and February and not really anything in December. No, I think that's a pretty big conclusion that we're getting specifically for North Dakota when we're looking at these normals.
Okay, and then I don't know if Rick can, if he was able to expand the questions to ask you. The other one from Erica then was, how do these changes compare to previous decades? So is that trend, was that the same trend we saw, say, from the 40s to the 70s that we saw from the 80s to the 2010s? Which I'm not sure you researched that. So are the trends we're seeing today, are they the same trends we've seen over the last, 50 or 100 years?
So I guess we didn't look at that in particular, but we do know that, the other baseline that's being used is the 20th century average. So, the 1900s is really kind of that baseline. And when we're looking at that, we are still warming. So we were cooler in the first part of that century, and then we've gotten warmer in the latest part of the century. So even with this, this localized cooling that we're having right now, in the grand scheme of things, it is still warming. And I think that ties back to, we don't know if this is going to just be a little temporary blip where the spring is getting cooler and the fall is getting warmer, or if that's going to be the trend for the next 10, 20 years. So overall, it is warming, especially looking at, the earlier, the 1920s, 30s, 40s compared to that, the 20th century average. But I guess anything more in particular, we would have to do a little research on and answer that later.
Okay, and then I think you'd have touched on this a little bit with the drought conditions. It was the Bowman Pioneer had asked, how are drought conditions throughout the state impacted by the findings? Is that the one you mentioned, like Alan is more the drought expert?
Yes. Yeah.
Yeah. What I would say to that is that a drought in 2021, let's say a drought started January 1st and went to December 31st in 2021. The same, we had this, whatever amount of rain we get in 2021, the drought would be worse in 2021 than it would in 2020 because the normal precipitation has gone up. So the normal precipitation, let's just make up numbers and say used to be 18 inches, now it's 19. So last year, if you got 10 inches, well, you were 8 inches below normal, but this year with the new normals, you're now an extra inch below normal. So the drought would be actually worse because the normals for precipitation are higher. Hopefully that makes sense.
Yeah, and I think that ties, and again, I'm not a drought expert by any means. I've picked up on a lot from Alan where there's different types of drought. There's meteorological drought, there's agricultural drought, there's hydrological drought. So it's kind of not one easy answer of just looking at the meteorology of it. They do consider the impacts and the current conditions and things. So on one hand, the normals maybe don't mean too much, where we could still be, you know, kind of close to normal, but if agriculturally and hydrologically things are looking bad, that might be more of a factor into the actual drought monitor and the drought conditions. So it's kind of, there's a lot that goes into that. But yeah, if you have drought specific questions, we would definitely refer you to Alan Schlag, our hydrologist, or the state climatologist Adnan, because they are much more in charge of helping create designate conditions for the drought monitor.
Yeah, all else being equal though, all else being equal, less rain or the same amount of rain as before, but the normal being higher means things are worse, right? We're in a worse situation.
And
yeah.
that's where it's
The other, let's see, there was a question also about, are there plans to expand the number of stations throughout the state?
yeah. I don't know if Rick knows anything about that, our data manager.
Well, as far as for precipitate, we're always getting new resources, new you know, if you want to include the whole the whole picture, we're always getting new weather stations, but strictly going by what we're right now using for normals with Coco Ross and the co-op. The co-op it's very challenging to get somebody to commit to taking those observations every day. Just 2 years ago, I had 5 folks interested in setting up a precip site. And then if they were going to continue to monitor precip, we were going to add temperature to it. And out of those 5, 4 of them quit within 4 months. So co-op is a very, very, very big challenge to keep, you know, we keep at it. We keep trying to get people, and we have picked up a few good ones. Quite a few good ones actually over the last several years. Coco Ross, on the other hand, that one is growing fast. Every year we seem to add, especially in March when we do our our advertising, March Madness, strictly precip. Coco Ross network is growing very fast, and that's an excellent resource to supplement, you know, any co-op sites or anything, and we're using those for the normals now. So that's a really good one. And yes, I guess the short answer, I made it a long answer, but the short answer to all that is, yeah, it is growing. You know, Coco Ross is doing well. Co-op is a little bit on the slow side. And then you've got another whole vast mesonet of personal weather stations and all that stuff that aren't figured in the normals. Mm-hmm. But I would have to just say, yeah, the Coco Ross part of everything seems to be growing very fast. So I guess the short answer is yes.
All right, Shane.
And then Rick, on the co-op side, Rick, what is the salary of those National Weather Service official co-op observers? What's their annual salary?
That's right. They're volunteers.
They're volunteers. Okay, so then you know what the salary is with that. Say, Darren Langerud asked a question, Megan, on with regard to the lower number of 90-degree temperatures in Jamestown and warmer minimum temperatures. Was there any consideration to dew point? He says that there's significant change in crops being grown in southeast North Dakota, corn and soybeans in the last decade that could be contributing to these observations. So with the 90 degrees, I was very surprised at that too at Jamestown.
I know, I was.
Yeah, any consideration to dew point?
I'd have to look into that.
Yeah, I'm sure that data is available.
Climate Center, yeah.
Yeah, we just did not look into that, but that is a really good point because, you know, that dew point is certainly going to influence, you know, what the temperature feels like. So yeah, no, that's actually a really good question, Darren. We're going to have to look into that because I do not know the answer right now.
And the last one I see, Megan and Rick, is any way, and this I thought was a great question, any way to incorporate the end-on stations, there are so many of those, right, into the mix?
There are so many of those, and we are very appreciative of the end-on stations. And that's, I guess, you know, a number of expanding stations. End-on is a really big one because they are always putting in new stations, and that is great news for us. As far as the climate normals, I don't know that they quite have enough data at this point because they are going to need the 30 years, and I don't know when all
Maybe
of
a
those.
15-year. That'd be a
Yeah,
good question for the climate.
That would be.
The Climate Center.
Yeah, I mean, I feel like eventually, if they're around long enough,
Well, I know
they would
they
be.
they're doing Cocoa Ross.
Yeah.
They should definitely be doing end-on.
Right. So yeah, so it might just be maybe they didn't start quite soon enough because they would have to be active for the full 30-year period. But hopefully eventually, because yeah, there's the end-on stations really help us out, and just, you know, that's such a good mesonet to have across the state because yeah, we don't have a lot of ASOS stations. Even the co-op stations, you know, are few and far between, which if there's any interest in being a co-op observer or a Cocoa Ross observer, you know, they're volunteer, but we would really appreciate it. You can always ask us if you want to do something like that. So yeah, that's
Plus, you get to share the information from your backyard, right, Rick, with that?
That's right. You get to see it. You get to see it on the website even.
yeah.
Exact location.
Yeah. And of course, that goes out when we get those, that goes out to all the media. And so you may see it in the newspaper or hear it on television weather. Well, that was the last question, guys. And that was from the Bowman Pioneer, who, so the media on today, and they had a lot of good questions for us. Yep. That was, I don't see any new questions unless Rick does on his display.
No, we don't see any new questions. Nice. Well, our hour is about up. So, I mean, if there's any last questions, we would be happy to answer those. But I'm not seeing anything. We'll go back to the end here. Any last questions? All right. Well, thank you all so much for attending. This has been a lot of fun, and we got some really great questions. So like I said, this webinar has been recorded, so we will be emailing out a copy of the recording as well as a copy of the slides. So that way you can have these links and you can also have our contact information. Please do not hesitate to contact either Rick or myself or both of us. If you ever have any climate questions, we would be happy to help you out. Thank you so much.